Right, I won't be talking much during this because I'm full of cold still. Yeah, it makes me cough my guts out when I start talking too much because I've got a very soft throat and that. So, but basically, I'm just making a delay line that's using a copper tube, which is a conventional way of creating a delay line. Either brass or, well, copper actually, but I'm using brass actually. It's a very similar material. Anyway. So I'm starting from scratch with this mounting. Might as well do it next to my switch. I need to hide a few things. Oh, damn it. I might as well hide that one as well. So the tube basically sits between those pillars. Yeah, this is the tube. I have to basically create the tube so I can make the other components that rest on it, the slider, the tapping, well, the variable control. It's going to rest on there. It's going to have coil on there, wire on there, so I've made it a fraction bigger. So so I need to create a runner. I've already cut my copper, well, my brass tube, and the idea is that I can put, it's hollow tube, so I can actually put a piece of steel inside the tube if I want to increase the inductance, or I could even put some new Alnico material inside the tube as well, which would create even more delay. So it makes it much more practical to make tuning adjustments and in changing inductance by using a piece of brass tubing, because it means I can change my core material whenever I want and try out different materials, which is really useful when you're trying. So basically I need a piece of material that will slide along that runner, and the best thing to do, I suppose, with that is simply use a piece of plastic and have it clipped through there. So simple, really. So let's do a piece of rectangular material. I'll just draw it on the face of this. I want to be 4mm. And my gap is 1.1mm. It's very thin, but it's going to be okay because I can make that gap a bit bigger. Actually, I think I will make that runner a bit bigger so it's not going to be too flimsy. So 0.5 on there. Let's have a look straight down. Yeah, that looks pretty good to me. So that should be about 1mm now, a bit over 1mm. It's 2.1mm. That's good enough. That'll work. So my material wants to be, hang on, two millimeters. I'm going to make that into a group. Edit group. I'm going to get a decent height. About the same height as that. Bring that down a bit. Right, and I want to make a little slide thing to catch on to everything. So what I'll do is I'm going to do some recessing underneath as well, so it doesn't stick out. So what I'm going to do here is put a lip about 1.2mm. That way I can it will snap into place basically. Pull it out by 1mm. That's a bit too much. Just pull it out by 0.3mm. All of this needs to be moved in a minute, so I'm just gonna hide that a minute. I don't want this sticking out too much, as I'll never get it in, but that thing in the middle will spring, so this should snap in quite easily. All of this needs moving back now, and by 2.9 millimeters. A little bit more. Good enough. So my contactor will be about here. So if make a dot there, and a dot there, hide that again. So my contactor will simply be a piece of copper tape, and how wide is that tape? I've forgotten now. But let's see, it's about 6 millimeters wide, so but it's going to have a smaller footprint than that when I put it on here. So the total width of that is 4 millimeters, so it's not wide enough really for the full width of tape. That's okay. I'll just make this a bit wider or something in a minute. Actually, I'll add add 3 on there. What is that blue line for? Oh, it must be my axis. So so we've got a 7 there. It's just approximate for now. I can make adjustments in a minute. So. The tape just threads through that slot, and I'll make adjustments. So I want that a bit thicker than that, so I'm going to go up by 1. The tape's not thick, actually that's too much. The tape's very thin, so let's see about that. Yeah, I want to be up about another 0.3. Down by 0.3. I'll thicken this out a bit, it's a bit too thin. I mean, remember, this is very tiny, this thing is. Get a bit of perspective. So basically I'll just thread the tape round through there. I want a nub in the middle where the contact point will be. So five millimeters, 5 divided by 2.5, so I'm going to go with 2.4. And this will make the contact area. It will cause the copper tape to stick out at this point. I think that's too much. I want a slight point on it. Let me just check this width. I've got to print this out, remember. 0.2 millimeters, no, that's not going to work. So what I'll do, I'll bring this out by 1 millimeter. Bring this out by 1 millimeter. Right. Clear my guides, and I'm going to bring a point from the centre. There we have it. So that's going to push that copper into a point where I can have a contactor point area. Because it's only copper tape, if it breaks or anything, I can replace it easy as well. So that's my slide for the copper wire that's on the tube. There'll be a certain area of the tube where that doesn't contact, well, where it can't go all the way to the end. but that's fine because I'm going to allow for the extra wire. So what I'm going to do there is I'll bring this lot back a bit. I'm going to add 3 and I'll recess that a bit. I'll take that in by 2. Okay, way too much. Yeah, 1.4. Right. Oops, wrong one. I want my ruler. Let's see. So that runner will move further than the, so I can accommodate more of that tube adjustment. I can't remember now. How much I moved the other one by? What was it? 2.7 was it? Or 1.7? No, it's 3.7. That was it. Right, so my runner can move further along. I can take this back a bit as well. So there should be enough back tension in the actual piece of plastic, but there's no worries about that. If it doesn't come into contact, I'll just put a spring on the base on the back of here to push it forward a bit. So there we have it, and my copper tube brass tube actually. So let's select all of this lot and put it in a new group, so it's all in one group, and that's going to be my slide attenuator. When the wire's wrapped around that tube, I could just move this along. This brown adjustment, I'll just slide it along to fine tune my delay line. And because it's a long piece of tube, if at some point I wanted to make it bigger, I could just stretch the whole thing out and make it longer, but I think that's going to work. If you go and look back at old TVs, you'll notice that they have a delay line or a variable resistors based very much on this design. So underneath, where these little lugs come out, I need to basically bring that up a bit. So edit group, and I need to .2 millimeters. .2 or .3, I'm not fussy. I'll bring that down until I've got clearance for my thingy. That's my runner. I'll be the same height as the other one. There we go. So this will basically be a snap bit, it'll just push in. And I've got my runner there. And it's flush on the base, so it's not going to stick on anything. But, just to make people happy, I could reduce the height of that a bit, but I think I'll leave it flat because then it will run on a flat surface, it will keep everything perked up vertical instead of it tilting when I move it along. So I'm going to leave that as it is. I can always sandpaper that if I need to. So that's the base sorted out. And the next job is printing all those components out. So let's print all this, export it all. Basically print it and test it and see if it's any good. See if I need to make any changes to it later. Come on computer. Oh, it's because I'm streaming, it's very laggy. I think I'll put this in another folder. Obviously I don't print the brass tube, but that's just for reference. Right, that's that. I didn't make any holes for mounting it, any screw holes, because, well, I'm probably just going to super glue it onto the PCB. I could have made some holes in this to mount it, but it's experimental, it's to test it, so I'm not fussy about holes. I can drill holes later if I need them. There's a large surface of body right here where I could drill holes if I needed to. But also I could stick the whole thing onto a circuit board with double-sided tape, because this is pretty small. We're talking about from that end to that end it's 51mm, so I mean it's going to fit on a circuit board without any problem. That is very small. Not very, very small, but it's small enough to fit onto the circuit boards that I've been making. or I don't even have to have it on the circuit board. I could mount it separately and just solder wires to it, solder the wires from the coil onto the circuit board. So yeah, so let's have a look at what it looks like in the Sketchup program. I mean in the preview netfab thing, see if there's any errors. So that's my contactor. Let's open the other part of it. Yeah. It's actually very similar to those parts I made from my 3D printed cutting table. Some of the parts were very similar to this, so I don't see any problems with it really. Right, that's it for now.